Hi, welcome back to another video where I study for the JNCIE-SP. So last video we looked at more depth into port channels. We did a custom topology, setting them up. Haven't been able to get LACP to work in GNS. I did talk to the same coworker that helped me out before and he was able to do it. So I don't know, I might need to just review how to set up LACP, but as I mentioned in the last video, I think I made 6 videos in that one topic. So I really just had to give up and move on. I need to be really careful about the amount of time I'm spending per topic so that I can cover all of the material on the exam. So a big part of that too is going to be OAM. From what I understand, there's really no chance that that won't be on the exam. And it's not listed specifically on there, but this was link aggregation, including fault detection. So I kind of figured that fault detection was something that would be done through OAM. So I wanted to practice there. So I set up OAM according to a lab, and that too I had trouble with, but I have some professional experience using OAM, years of that at the command line, typing that stuff out. So I'm familiar with MEPS and MPIDs and CCMs, all of that sort of thing I'm pretty well familiar with. So I'm just gonna have to lean into my professional experience for that topic if it comes up on the exam. So this is going to be a new topic in this video. This is the first video in this new topic. It's still going to be part of high availability, but it's now going to be graceful restart. All right, so I've got 2 labs preloaded up in here. So this is configuring ISIS for GRES with graceful restart. Let's take a peek at what the other one is. Configuring ISIS for GRES with graceful restart. It looks like it's the same one. Yeah, it looks like the same one. So I'm just going to delete one of these. I might take a closer look at the URL. Yep, URL is exactly the same. So I'm going to delete that, and then we're going to just do this here and then move on. All right, so this example shows you how to configure the routing engine's graceful restart protocol extensions using the intermediate system to intermediate system, ISIS, interior gateway protocol, IGP, to successfully enable graceful routing engine switchover, GRES, with graceful restart. GRES, graceful routing engine switchover, prevents interruptions in network traffic if the master routing engine fails when combined with either graceful restart, nonstop active routing, NSR. Before you follow the directions here to configure graceful restart, be sure you have enabled GRES, which is disabled by default. So let's see what kind of topology this might have. So there is no topology listed, so let's just use the topology I already have up. And hopefully I don't have the error where, so I do have the CLI. Lucky not to have that, but it wouldn't have been a big deal because there's a lot to read, so the reboot could have happened in the background. Let's take a look at what's on here right now. Oh, so yep, all that configuration is on there. So let's put it in a better state. Yeah, so let's make things a bit more simple to work with. I'll actually remove the port channels too because I want to be able to sniff the links easier. Okay, so it's going to be a really simple stripped down configuration. We're just going to have a point-to-point connection between router 1 and router 2 over one link so that we can pull up a Wireshark capture on it more easily. And then we'll be able to configure ISIS and hopefully explore some of this capability. So let's commit this configuration and then set up a similar configuration on router 1 and then change the wiring. All right, so it's time to change the wiring. And I'm not sure how to practice routing engine failover. I'm hoping what I can do is just enable two control planes. So Juniper, you have the control plane and the forwarding plane hooked together. So I'm thinking if I can just have, did I say two control planes? I meant two forwarding planes. If I can just have two forwarding planes, I'm hoping I can then explore that topic where it fails over between forwarding planes. So I'm hoping I can do this in GNS3. We will see. Overview. If adjacencies between the routing engine and the neighboring peer helper routers time out, graceful restart protocol extensions are unable to notify the peer helpers about the impending restart. Graceful restart can then stop and cause interruptions in traffic. To ensure that these adjacencies are kept, change the hold time for ISIS protocols from the default of 27 seconds to a higher value than 40 seconds. If your system uses the open shortest pathway first, OSPF protocol instead of ISIS, see this example. Each interface must be set individually with a value for each level that the routing interface operates on. The minimum recommended value of 41 seconds is used in this example. Your system may require a higher value based on size and traffic. Level 1 and level 2 can be set to different values. Okay, so let's put this configuration here on both sides and make sure that the ISIS adjacency comes up between router 1 and router 2. Oh, but it's not going to, because we know just from past experience that it takes more than just enabling it on the interface for ISIS to come up. We also need a NET identifier. We need family ISO enabled. So it's more than just adding the interface to the protocol ISIS configuration. But we'll start there. I'm surprised it's not, I'm surprised it's not talking about that more. I guess it kind of assumes that you've got a lot of knowledge. I mean, usually it'll call out, like, if you need help, like, you know, as it did there, but it's not doing that. Let's do the step-by-step. So to configure the ISIS hold time for graceful restart. Okay, so this is just the example to configure the hold time. So this is graceful restart. This actually seems like, unfortunately, it's not the best best example. Let's see if there's a better one. Juniper graceful restart. Here we go. High availability user guide, perfect. There we go. This looks a lot better. Yeah, I guess I would rather just, yeah, let's just read through this and use this as the documentation. Okay, perfect. So here's all the, here's more what we need to know for the exam. Enabling graceful routing engine switchover. So, oh, what about graceful restart? Okay, there we go. So this is a requirement to graceful restart. You've got to enable GRES, graceful routing engine switchover first. So let's do that. So it's edit, chassis, redundancy, set, graceful switchover. And let's look at the help for that. Enable graceful switchover on supported hardware. We might not have that. Let's look at the help for redundancy. So redundant settings. Okay, so we've got failover, graceful switchover routing engine. So let's set graceful switchover. Oops, switch port. Perfect. So when you enable GRES, the command line interface indicates which routing engine you are using. So, and this is one thing, if anyone watching this has seen a Juniper in the real world, you might be wondering, oh, where is this? You know, this looks different than how I have used it. I've only seen this master popping up. Well, there you go. There's your answer. It's because graceful switchover has been enabled. So it's keeping track of which routing engine is the master and which one it would fail over to. To disable GRES, graceful routing engine switchover, delete the graceful switchover statement from the edit chassis redundancy hierarchy level. So let's just do that again to get some more practice. So edit chassis redundancy, and then we're going to do delete, and it's graceful switchover. Yep. And then you'll see that master disappears. So let's add that back in. Set chassis redundancy, graceful switchover. So now we get that master showing up again. And we also get this warning here. So I'll demo that warning again. I'll just put a description on G000. And I'll say C message. All right, and now I'll do the commit. So the warning is graceful switchover is enabled. Commit synchronize should be used. Let's take a look at the help for commit synchronize. Synchronize commit on both routing engines. So if I had 2 routing engines, which I'm going to try, but right now I only have 1, so it's not going to be a big deal. When it fails over to the other routing engine, the command, the configuration that it will boot up with won't have that configuration because I only committed it on the master routing engine. So you really gotta use that commit synchronize if you want it to be on both of your routing engines. So that's important to know. But I only have 1 routing engine, so that's going to be, I think, a really good test to see if this will work. Let's do that right now. So on the GNS3, I'm going to move this over here, and then I'm going to get another forwarding plane. So I'm not sure where my forwarding plane is. Definitely placed it here. Let me just try reopening GNS3. I think there's a refresh button. No. Oh, just the refresh list here, but I don't think there's a refresh button here. There's a reboot button, but not a refresh. Okay, so let's try plugging this into the R1 so that it has redundant routing engines. Oh, and already we can't do that because we've only got 1 interface, that EM1. The other interface is just for management, so we can't plug it into there. Let's see if we can get a second interface on here. So network, adding another interface, apply. Oops, so we've got to delete the links first. That's easy. I don't know where this R3 came from, so I'll just get rid of it. All right, and now I will try to add a link now that there are no links set up. Perfect, so no complaints. Now we can add our routing engines back. We've got EM1, we've got EM2. Oops. Oh, okay. And I'm actually going to plug this one into EM0, or sorry, EM1 on router 1, just because that's how it was before. And I think it's less likely for there to be issues. So let's boot up that forwarding plane. And it looks like there's an issue with GNS not recognizing the adapter or something. So I'm going to do the tried and true, close it and then reopen it again. Oops, there we go. All right, so now it's open again. So hopefully we won't get those issues. Aha, so here's the problem. We added another link to the image in GNS, but the actual virtual machine itself still does not have that link. So in order to add more links in GNS, you've got to have them actually exist on the virtual machine. So let's see if we can do that. Let's do an edit on the control plane here, and then go network and increase it here. Apply, okay. Okay, and now we're gonna need to make new images, but I don't think there's any issue with doing that. These are, I just blanked them out before anyway, so I'll have those deletes, close it, open it again, and then we'll just focus on trying to get redundant forwarding planes working in GNS3. All right, so here's the control plane. It'll have the appropriate number of EM interfaces now. I might need to add one here, but I will have the ability to do so. Nope, I don't need to add it, it's already there. So I'll do, now these are all fresh, I'll just do the left one to EM1 and then the right one to EM2. Perfect, and now I will run everything, and then on CP1, enable that graceful switchover, so we'll see the master, but you should also have the ability to see the standby or backup as well. And when we do that commit that we did before, we commit synchronize, I don't want this, commit synchronize, it will show that it's committing to both forwarding planes, RE0 and RE1. All right, so looks like the links are green, so hopefully this CPE is booting up. Yep, it's booting up. So I think I'm gonna let that boot up for a little bit, and I'll be back in a second, and hopefully it will be booted up by then. All right, so I am back. Looks like it's still booting up, but this is probably a good opportunity to do some more of the reading. So configuring graceful routing engine switchover with graceful restart. When using GRES, graceful routing engine switchover with graceful restart, if adjacencies between the routing engine and the neighboring peer helper routers time out, graceful restart protocol extensions are unable to notify the peer helper routers about the impending restart. Graceful restart can then stop and cause interruptions in traffic. To ensure that these adjacencies are kept, change the hold time for ISIS protocols from the default of 27 seconds to a value higher than 40 seconds. Synchronizing the routing engine configuration. Note, a newly inserted backup routing engine automatically synchronizes its configuration with a master routing engine configuration. When you configure GRES, you can bring the backup routing engine online after the master routing engine is already running. There is no requirement to start the two routing engines simultaneously. Only when you enable the graceful routing engine switchover, you can copy the running Junos OS version of the master routing engine to the backup routing engine. Note if the system is in ISSU, and this was part of the JNCIE-SP ISSU. Unfortunately, right off the top of my head, I don't remember the acronym or really anything about it. I kind of took that a while ago by now. You cannot copy the running Junos OS version of the master router engine. Starting in Junos OS release 14.1, you can enable automatic synchronization of the master routing engine with the backup routing engine by including the events chassis D SNMP trap 7 statement at the edit event options policy name hierarchy level. So yeah, I'm not sure this is going to be part of the exam. So this is to verify. To verify whether GRES, Graceful Routing Engine Switchover, is enabled on the backup routing engine, issue the show system switchover command. When the output of the command indicates that the graceful switchover field is set to on, then GRES is enabled. The status of the kernel database and configuration database synchronization between routing engines is also provided. Aha, and this I remember was something I needed to know for the IP. So you must issue the show system switchover command on the backup routing engine. This command is not supported on the master routing engine. Okay, so yeah, I mean, we can read the whole understanding article. If it's going to take that long to boot up, might as well just use that time instead of just letting it go to waste. Graceful Routing Engine Switchover Concepts. The Graceful Routing Engine Switchover GRES feature in Junos OS enables a router with redundant routing engines to continue forwarding packets, even if one routing engine fails. GRES preserves kernel interface and kernel information. Traffic is not interrupted. However, GRES does not preserve the control plane. Neighboring routers detect that the router has experienced a restart and react to the event in a manner prescribed by individual routing protocol specifications. To preserve routing during a switchover, GRES must be combined with either graceful restart protocol extensions, nonstop active routing, NSR. Any updates to the master routing engine are replicated to the backup routing engine as soon as they occur. Because of its synchronization requirements and logic, NSR-GRES performance is limited by the slowest routing engine in the system. Master ship switches to the backup routing engine if the master routing engine kernel stops operating, the master routing engine experiences a hardware failure, the administrator initiates a manual switchover. To quickly restore or to preserve routing protocol state information during a switchover, GRES must be combined with either graceful restart or nonstop active routing, respectively. For more information about graceful restart, see graceful restart concepts. For more information about nonstop active routing, see nonstop active routing concepts. If the backup routing engine does not receive a keep alive from the master routing engine after 2 seconds, 4 seconds on M20 routers, it determines that the master routing engine has failed and assumes mastership. The packet forwarding engine seamlessly disconnects from the old master routing engine, reconnects to the new master routing engine, does not reboot, does not interrupt. The new master routing engine and the packet forwarding engine then become synchronized. If the new routing engine detects that the packet forwarding engine state is not up to date, it resends state update messages. Starting with Junos OS release 12.2, if adjacencies between the restarting router and the neighboring peer helper routers time out, graceful restart protocol extensions are unable to notify the peer helper routers about the impending restart. Graceful restarts can then stop and cause interruptions in traffic. To ensure that these adjacencies are maintained, change the hold time for ISIS protocols from the default of 27 seconds to a higher value higher than 40 seconds. It's got to be 41 seconds or higher. That, I'm pretty sure that will be on the test, changing those hold timer values in ISIS. I mean, I don't know what's going to be on there, but this is very clearly an essential part of having graceful restart work properly. So, all right. So this is almost up. This is like the last step in getting the CLI and the VMX to come up, that unlocking device. Sometimes it goes faster than other times. Seems to be going pretty fast right now. So that's going to be up real soon. Don't think those notes are going to be necessary. Let's read the switchover preparation process for GRES. Number 1, the master routing engine starts. Number 2, the routing platform processes, such as the chassis process, start. Number 3, the packet forwarding engine starts and connects to the master routing engine. Number 4, all state information is updated in the system. Number 5, the backup routing engine starts. Number 6, the system determines whether GRES, graceful routing engine switchover, has been enabled. Number 7, the kernel synchronization process, JNCIE-SP, synchronizes the backup routing engine with the master routing engine. Number 8, after JNCIE kernel synchronization process completes the synchronization, all state information and the forwarding table are updated. The switchover process comprises the following steps. When keep alives from the master routing engine are lost, the system switches over gracefully to the backup routing engine. The packet forwarding engine connects to the backup routing engine, which becomes the new master. Routing platform processes that are not part of GRES, such as the routing protocol process RPD, restart. State information used from the point of the switchover is updated in the system. If configured, graceful restart protocol extensions collect and restore routing information from neighboring peer helper routers. For MX series routers, the routers that will be used during the exam, using enhanced subscriber management, the new backup routing engine, the former master routing engine, will reboot when a graceful routing engine switchover, GRES, is performed. This cold restart resynchronizes the backup routing engine state with that of the new master routing engine, preventing discrepancies in state that might have occurred during the switchover. Okay, so I'm going to stop reading and get this set up. Hopefully it will. Let's see here, delete system, delete. I'll just do a delete. Yeah, this is the fast way. And then I'll re-add this version command, set system, root authentication, plain, set chassis, network services, enhanced IP. So I think, oh, one thing's missing, the host name. Just call it R1. All right, so everything is at its default configuration now. I am missing my license, so I'm gonna add that. I'm gonna fortunately stop sharing while I do that because I don't wanna hand my license away. So let's pull up that license, and again, you can get your own by contacting Juniper. Yeah, it's free of charge. So just call them up and tell them you're studying for an exam. Provide them with an email. All right, but I am going to add this. All right, so my license key has been added. The command for that is request system license add, and then you can choose how you want to add it. My preferred way is the terminal. So now I can share my screen again. Perfect. So now we're going to be enabling the switchover, graceful switchover, GRES, graceful routing engine switchover, and then we'll be able to set up graceful restart once GRES is set up. So I'm going to try to do that from memory. So set chassis redundancy, graceful switchover, really easy. Okay, so now we've got a master. So let's do a commit synchronize. Oh, okay, well, it looks like it just committed to RE0. I didn't see anything for RE1. So unfortunately, I don't think that worked. Let's do a show in terse pipe match EM. And oh, we do have EM1 and EM2. So it looks like we do have the second routing engine there. Let's see if we can log into that second routing engine and do that extra command on there. Yeah. So let's see if we can. Oh wait, where was it? It's oh, go away. Control panel. There we go. Here we go. Oh, that's on port channels. Here it is. So configuring it. So here's where it said, yeah, or, well, where was it? Here we go. Only when you enable, no, where's that part where it said that, here we go. So you must issue show system switchover command on the backup routing engine. So if I do it here, this is the master. No such command. So unfortunately, it looks like I'm just going to have to kind of piggyback on my professional experience here and okay, just try to figure out how to get in there. I remember I've done this before, and the way I did it was telnetting into the other engine. But that actually might not have even been on a Juniper now that I think of it. So yeah, I need to figure out how to go and enter this command. So let's see here, show system switchover. I'm gonna Google for this. But we need to figure out how to log into that other control plane. Looks like they're not giving any instructions for how to do that. So Juniper log into RE1. Yeah. Here we go. So request routing engine login. Oops, but we probably need to specify the engine. Yeah, RE1. No route to host, unfortunately. So yeah, I'm not sure. Not sure what's going on there. Or if we just do backup. No route to host still. What about RE0? Okay, so we were able to log into RE0, which is interesting because we're already logged into it. But as we saw, that's the master, so we're just able to log into RE0. But it looks like there's no route to host. Yeah, so it's expecting it looks like it's trying .5, which is interesting because you'd think it would try something from this. Here we go. So show chassis routing engine. So we can see we got a routing engine in slot 0. Let's see if we got a second routing engine. Nope. So only one routing engine was detected, the routing engine in slot 0. So we need to figure out how to put a second routing engine in slot 1. This is something I thought too. Maybe it needs a hub and it just connects to the routing engines through one link. That's certainly something I can try. Yeah, I'll try that. I've only got like 4 minutes left, so if that's going to be a simpler solution, I will try that and then go to a more in-depth solution in the after work video. So we're just going to be doing a layer 1 Ethernet hub, and then removing the links. All right, and now the hub goes here, and we're going to be cabling up these to the hub instead of to the switch. We'll use the, ETH1. Yeah, we have to use ETH1. The other interfaces are either gigabit Ethernet interfaces or management ports. So it has to be port 1. Okay, so now let's see if this is a bit different. Still Still nothing. Okay. So I guess I can try this configuration here. Yeah, I'll just try just adding all of this configuration. Okay, I don't know what password they're using. Oh, I see. root123. Okay, and then this syslogging stuff I'll leave out. It looks like this is just trace options. So I'm definitely going to need this. And then I'll just add this one just because. Okay, let's see if this commits. Oops. Okay, so that's fine. Let's see if we got a better outcome here. Nope, we still have only got a single routing engine. Let's try changing the wiring. Nope, still just the single. Oh, I do see a new FPC. We weren't getting this FPC showing up. Ah, nice. So it looks like something is happening now, but I don't know if that's going to lead to the ultimate solution here. Okay, so we've only got one slot still. Slot 0. Yep, so very clearly something is not right. All right, looks like it needs some special setup in QEMU as well. So yep, this is definitely the topic for another video. I might have to do the same thing I did with the last one though, where if I can't get through it all in one single video after work today, I might have to cut the topic short, unfortunately. But yeah, I'll definitely give it a try. So stay tuned for that. I'll see you in the next video. Thanks for watching.